I'm going to discuss the very beginnings of trigonometry. Trigonometry is a Greek word that deals with trigons, that is triangles, and metry is the measure of triangles. So we're looking at the measure of triangles. And there's one basic idea which we're going to explore more in class, which is really fundamental about triangles, is that if I am looking at a right angled triangle, so I'm going to make sure that this is a right angled triangle here. Okay, when I look at the ratio of sides, for example, this side, the yellow side divided by the purple side, or the yellow side divided by the green side, that ratio stays always the same. It doesn't matter whether I have large sides or small sides. The ratio stays always the same as long as my triangles are similar, which is the case when I enlarge the triangle. As long as the angles in the triangle are the same, the ratios of sides stay the same. That's the basic idea here. So let's look a little bit closer at this triangle. It would be useful to have some measures here. Okay, let's say this was 3 units long and this is 4 long. Then we can actually calculate this side using Pythagoras. Okay, we know from studying Pythagoras' theorem that this is called a hypotenuse. This is the name always given to the longest side, in this case the green side. And we can calculate the hypotenuse using Pythagoras' theorem, which is saying that the square of the longest side is equal to the sum of the squares of the 2 shorter sides. Okay, so c squared is 25, sorry. 9 plus 16, 25, and therefore c equals to 5. And so we've just calculated that this is 5 long. Now I can erase this bit here because I won't need it anymore. Right. Now, I'm going to start with giving you a little way to remember the key ratios we're going to look at today. We're going to have the sine ratio. Okay. We're going to have something called the cosine ratio, and we're going to have something called the tangent ratio. Okay, I'm going to write the full names here so you can see where they come from. This is the sine, this is cosine, and this is tangent. Right, but we usually use these abbreviations here. And I'm going to give you this mnemonic here. So, ka, and toa. You're going to see how this will be useful in a moment. Okay, so what we can, these are basically the names of 3 particular ratios I can create in this triangle. For example, if I focus on this angle here, I can divide that side by that side. Now I will call this yellow side, this is the opposite side. Okay, it's opposite to my angle here. And the purple side, that is adjacent. The adjacent side, it's next to that angle. That's what adjacent means, next to. Okay, right, and now I can start using my ratios. So the sine ratio is defined as the opposite over the hypotenuse. Okay, now, and this is where this comes from. Do you see? Sine is opposite over hypotenuse, right? Sine is opposite of hypotenuse. So now we're going to find the opposite to this angle here. The opposite is 3, and the hypotenuse is 5. So sine alpha equals to 3 over 5. That is the sine ratio. Ratios can also be written as a fraction. You can see that here. So 3 over 5. In fact, if I calculate this as a decimal number, I get 0.6. That is my sine ratio. Okay, and this number stays 0.6 no matter the size of my triangle, whether I make it bigger or smaller. Okay. Similarly, I have the cosine ratio. The cosine ratio is adjacent over hypotenuse. That's where these letters come from. Adjacent over hypotenuse for the cosine. And now I need to go and find these. The adjacent is 4. And the hypotenuse is 5. 4 divided by 5 is also 0.8. That is my cosine ratio. And finally, I can look at the tan ratio, which is opposite over adjacent. That's where this comes from. Tan is opposite over adjacent. Opposite of adjacent, the opposite is 3, and the adjacent is 4. And I get 0.75. Note that I will always get a number here between 0 and 1. So this word SOHCAHTOA is a way of remembering how the sine ratios work. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's really important to be very clear which angle we're looking at, because if I change my angle, if I start looking at this angle, I'll use the second Greek letter of the alphabet, beta. Okay, everything changes. I've got that over here. Let me just pull it into the screen. Let's have a look at what's written down so far. If I look at sine beta, sine is opposite over hypotenuse. Well, the opposite to this angle is not here, this yellow side. It's that one. So for this one, I should change this. This is not opposite of adjacent anymore. Now, this side is adjacent, and that purple side is opposite to the angle beta. So it's really important. This is opposite to the angle beta. It depends on which angle I'm looking at. That's why we always have the angle here also. Sine beta, okay, is opposite of hypotenuse. This time it's 4 divided by 5, not 3 divided by 5. Same for cosine beta, which is adjacent over hypotenuse. And then finally, tangent beta, which is opposite of adjacent. Let's finish that one. Let's look for the opposite to beta, which is over here, 4. And the adjacent is 3, which is 1/3. Okay. One last time, SOHCAHTOA. This is the way to remember these, how the different ratios, sine, cosine, and tangent work in a triangle. SOHCAHTOA. And to end with, here's a little quiz. Can you remind yourself of what SOHCAHTOA all stands for? Just check that for yourself.